I'm Sean Derrington, Group Product Manager at Storage and Google Cloud. Dean Hildebrand's in OCTO, our Office of CTO. So with that, I wanted to give everybody just kind of level set a little bit about what we're doing at Google Cloud. We have a variety of storage portfolio offerings, and obviously, because this is Cloud Field Day, we're talking about more than just our storage portfolio, thus GKE and some of the other things. But across the block, file, and object, we have persistent disk, which is on the block storage side. Really a different range of capacities and performance, and we'll get into more details there. On the object storage side, that's our cloud storage. And as you'd expect, that's where most companies store the petabytes or tens of petabytes, or in some cases more than that, storage for different application uses that aren't well suited for block or file. And on the file side, we have Filestore. This is our fully managed NFS storage service that customers can use for a variety of applications, and I'll touch on that a little bit later. But on the transfer side, we have ways for customers to get data into our cloud, as well as from other cloud providers into Google Cloud to use that information. And then lastly, we also have the data protection capabilities that are part of what we'll talk about today for GKE and GCE, as well as GCVE. So whatever VM or container you're running on, we can protect that. But if you'll notice at the bottom of the slide, we also have an open ecosystem approach. As much as we're doing as Google ourselves, we do want to do what's right by the customer. And some customers want to use other capabilities, for example, protecting their data with Veeam or Commvault, or as we talked about yesterday with NetApp, they want to use NetApp on premises and in the cloud and in a hybrid or even just in a pure cloud deployment model. So we do have this open ecosystem with partners in addition to what we provide ourselves. One of the things I just wanted to briefly touch on, even though this is not storage related, it does impact how storage can be architected in the cloud, and that is Google's network infrastructure. This is one of the things that is a differentiator for us in that it's an easy way for customers to get their data into the cloud very quickly, then have predictable and known either bandwidth and or latency between regions or between their data centers and our regions, and they can scale what that interconnect into Google's network looks like, whether it be a VPN connection or there be dedicated interconnects at 10 gig or 100 gig or multiple 100 gig even, depending upon what the needs are. But this is one of the things that, with 173 locations, it makes it easy for customers to get onto our network with the vast capabilities that we have with our undersea cables. You have a very predictable network compared to some other alternatives where you're jumping providers and going in and out. And then once you're on a network, you're actually on the same network that Gmail and Photos and all of the other infrastructure that supports billions of users is running on. And there are even estimations that we actually provide about 20% of the total bandwidth for all internet traffic. So it is one of the things that we're very proud of. It is one of the things that enables us to do a variety of things that we'll talk about. With cloud storage, I want to just kind of touch a little bit about analytics, where this is one of the combination of cloud storage and our object storage capabilities with the additional capabilities of Vertex or BigQuery and so forth for customers to gain more value of and with their information, whether it be with SAP or other applications. But this is where the storage transfer service that I talked about is one of the ways that customers can get data into cloud storage. So whether you're coming from another hyperscaler, S3 compatible storage from on-premises into cloud storage, you can do that as well. And we also manage the security, so identity access management that we would use with your Google project. It's that same type of security of who has access to move what data and get access to what data. The other thing that we want to focus on is kind of optimizing operations, right? So we want to make it easy for customers to move from where they are to where they want to go. And a good example of this is with either Hadoop or Spark, simply changing and keeping the same structure of the data, but just changing the path. So you don't have to rewrite a lot of the applications to begin to take advantage of some of those things with Hadoop and so forth as you use cloud storage. This is one of the things that we announced at Storage Spotlight earlier this month on the 8th, and that is our cloud storage Autoclass. With the amount of capacity that is in cloud storage, or I should say could be, one of the challenges is to optimize the placement of those objects across different storage classes. On the right-hand side, you see standard, nearline, all the way down to archive. These have different cost metrics. They have, fortunately, very similar performance metrics in terms of millisecond type response time all the way down to archive, right? So that's a very different approach to providing consistent millisecond type response times, whether you're standard or archive, as well as you have a consistent set of APIs across all storage classes, which makes it very easy to write an application to take advantage of different classes. However, We want to take it one step further and give customers that easy button to say at a bucket level, just by policy, migrate objects to different classes of storage over time. So they don't have to do anything. That object will be sitting on standard for 30 days. It'll be moved to nearline all the way down to archive over time. And the difference here is that we're making it easy for customers to not have to administer this either one at an object level, but because they can do it at the entire bucket level, but we're also eliminating any of the retrieval fees that would be sometimes associated with, or deletion fees that would sometimes be associated with deleting data that's out of an archive prior to like a year, as an example, right? So this is one of the things that a lot of our customers are focusing on. Yeah.
You said the performance was the same across all these tiers? So performance as an access to the first byte of storage is exactly the same.
I would say extremely similar across them all,
Similar.
like within individual milliseconds.
So if an object is sitting in archive, I can access it at the same level as a standard.
Yep. That is exactly right. Yeah.
Does it go the other way with the tiering? So if I access something in archive, does that put that automatically into standard?
It does.
Yeah.
Okay.
Yeah, so that's one of the things that we've done in the past is we made it able to go down the stack and get it colder, but we didn't really make that process easy to get it back up the stack again. And so here it's meant to be all both directions.
Okay.
Now, the weird thing on the business side of it, and a lot of folks that you talk to, and I'm sure that I've talked to, there's this weird enterprise meatware problem that we like predictability. And one of the problems that folks lack, visibility into what it will look like if they have X amount of data, X amount of compute, and there's, whether right or wrong, there's this human need to say, like, in a year, I will be spending this much in Google Cloud. But then because of the auto tiering, they don't know. So there's this weird trepidation.
Yeah. And that's one of the things, like actually with, so Redivus is a company that provides a lot of capacity for data analytics for the research community. And there's a hot and cold spell, right? So initially, new data, a lot of people are manipulating it, running research and writing reports and papers on. But then over time, people aren't going to access it until maybe 3-5 years later. They read the paper, they want to go back and do additional analysis on that. They're really excited about this because they can keep more data available for the research community because it's going to be automatically migrated down to archive. They're not going to have to manually figure out what data is being accessed when and do the manual operations of that. So I'm going to just talk really briefly. This is another differentiation for cloud storage. In addition to the millisecond latency across storage classes, is this idea of a continental scale bucket. So customers have the option to use either single region or dual region or even multi-region storage, but on a continental scale, they just define a bucket. And that means that those objects stored in that bucket are going to be spread across the regions that they determine. And that makes it very easy for them to, again, have a single set of APIs for that bucket. They don't have to worry about where the data is coming from. If a region is interrupted, the recovery time to get that data from the alternate region is 0. They don't know from an application perspective. There's no failover, failback needed with us. As well as we introduced the option for turbo replication. So in the dual region configuration, we have strong consistency. And you'll see this with DOM, so I'm not going to spend too much time on this. But we give customers the option to have a recovery point objective of 15 minutes between any 2 regions within a continent. So now there are 9 regions available across 3 continents that customers can choose to have a recovery time objective of 0 and an RPO of 15 minutes. And then I'm going to skip this last part, really, and I'll let Dom talk a little bit about this. But on the performance side, Dean, I don't know if you want to touch on that kind of the throughput. I think you did a blog like the 10 terabits per second.
Right. Yeah. I mean, so I think one of the interesting aspects that GCS does is, as to your question before around the archive tier, I mean, so it's doing data preservation workloads on the archive side, but the exact same API is then scaling terabits per second and also delivering the bandwidth to retail, FinServ, and a variety of other customers that are really exploring it as a high performance option in HPC or big compute or whatever area that they're working on. And so, if you combine all those together, right, then between the Autoclass and then not having to worry about when to preserve the data and make it cold, but then also be able to scale up to terabits, that becomes just a really simple solution for developers.
So one of the things that we introduced at Spotlight was backup for GKE. As we've seen more and more customers wanting to run stateful workloads, now they need to begin to thinking about applications like SAP, but now in a container environment, right? And so with backup for GKE, we actually provide customers the option to, in Google's Cloud Console, with a few mouse clicks, define backup policies for particular namespaces, entire pods, an individual application or cluster. Gives them a lot of granularity to do this. And don't worry about trying to read this screenshot. Manu's going to do a demo of this later today. But this is one of the things that is, again, well, not again, but it's one of the things that's unique to Google Cloud, in that we actually provide a native integrated console backup capability for Kubernetes. This is an architecture, and I want to just highlight that we do give that granularity between what and how you want to protect applications running in GKE, and assigning different policies even within applications in a pod, right? So it gives a lot of granularity for that. Yes. Yeah,
Does that have the capability to leave Google storage footprint at any point in time for those backups? Or is it going to land into Google storage? Your backups are landing into Google storage as well?
The latter. The backups of GKE will land in Google's cloud storage.
Is there a way to do a secondary copy that is not Google Cloud Storage?
Not today.
Okay.
And is this
To replicate it across regions or something like that.
Exactly.
Yeah.
is this a
could- yeah.
propri- is
No,
this
go
a-
ahead. Sorry, go ahead.
Sorry. Is this a proprietary backup engine, or is this open source Flare based?
This is our own. Yeah, we developed this.
Yeah, it's directly part of the infrastructure.
Just for grins, what's the storage for GKE?
Persistent disk, file store, or cloud storage.
So it gets back to the workload, basically. What workload are you running in GKE? And then that's where the storage comes from.
And Ray, I will give you the $10 for queuing up the next slide for file store for GKE here. Okay, it's perfect. This is one of the things that, depending on the application workload, sometimes you need thousands or hundreds of pods to write to the same storage. And so with file store and NFS storage, you can now have multiple pods all mount that same NFS share. And that's all good for multi-writer scenarios, or if you need availability, if a pod fails, the other one picks up and it still has access to the exact same data, as opposed to unmounting and remounting and recovering data, right? As well as with file store, we have 4 nines of regional availability. So we actually replicate the data synchronously across 3 zones within a region, so that if a zone goes down within a region, you still have 2 available zones. NFS is still serving up the data to n number of pods and number of clusters that GKE is mounting, as well as we've given now the customer's capability to more granularly assign storage to pods. So you can go down as little as like 10 gig per share and assign that out to n number of pods. And so you have this notion of a larger capacity of file store, terabyte, 10 terabytes, and you can allocate smaller capacities for that. You can also use different types of file store. So we have higher performing file store that upwards of 1 million IOPS for 100 terabytes capacity, or 26 gigabytes per second of throughput. A lot of times you don't need that much capacity with GKE, and so there's a file store enterprise availability, as well as performance, a little bit different than high scale, but it really depends upon what the customer and the application needs are.
Yeah, I was just going to say, so this kind of gets into the 2 spectrums that we're trying to deal with in terms of user workloads, in the sense of a lot of workloads in GKE are just needing small amounts of data that they're sharing across the cluster. Maybe it's binaries, maybe it's just tooling, or maybe there's some persistent data in there as well. But then all the way to the other end of the spectrum, which gets back to actually they're deploying HPC and high performance jobs inside GKE now, and using it as really like a scheduler to launch, drug discovery and other type workloads. And then we need, they don't need the multi-share as much as, but they would need the high performance and the high capacity side. So it's like really the spectrum between those 2.
For the scaling options, one of the things, of course, many cloud platforms, I don't want to name competitors, but you know them, scale up easy, scale down no. Like often, especially when you do high performance tiers, the only option is to scale up. And while we'd love to think that you could just run in one fantastically large Google cluster or Kubernetes cluster, we don't. We run in purpose-built clusters. And so as we see workloads move, we have this problem where we end up with this, we have to kill a cluster to get rid of storage. What's the dynamics around scaling up and down?
Yeah, so with the CSI driver, you can create with, again, different file store tier. They all support the CSI driver, and then you can create your storage pool and storage class, and you can scale up or scale down that capacity as needed. So the file store enterprise starts at 1 terabyte, and you can carve up 100 shares, so you can get down to 10 gigabytes, 10 gigabits per share, and allocate that to n number of pods. For file store high scale that Dean was talking about for the high performing needs, that starts at 10 terabytes. That does not have the multi-share capability. but enterprise is smaller capacity performance does. There is a link down here in our documentation for the new capability. If anybody's interested in playing around with that, that's available as well.
And then just to link that into the point that the GKE cluster itself can scale up and down. So then this way, you don't need to worry about storage disappearing or anything like that as you scale down your cluster on that side as well.
On behalf of all managed Kubernetes users, thank you.
Yes.
Quick question on that front. So let's say we have persistent volumes in region A and we need to fail over to region B from a Kubernetes perspective. Would we be able to use some level of file store cross-region replication to support that, or would you be recommending the integrated backup and restore service that you just covered?
So two parts to that answer. Today, it's the latter. It's the backup and recovery of that data. But as you'd imagine, asynchronous replication for file store is one of the things a lot of people would need, and that is on a roadmap for next year.
But Filestore Enterprise also supports a regional storage offering. So you can combine the regional file store storage offering in Filestore with the regional GKE clusters that you can deploy as well. And then between the two of them, you're getting a regional offering in both dimensions.
In addition to using snapshots for Filestore Enterprise to protect the NFS data, the backup for GKE works with persistent disks today, but you have the way to protect the file store data, individual file or entire file system, and you can recover that in less than 10 minutes with the snapshots, regardless of the size. Yes.
And when you mentioned regional, you're defining regional as multiple different available, multiple different zones, data centers
Within a region.
within that region, right? So you still have a high level of availability in that type of synopsis. You wouldn't be looking at multiple regions like East Coast, West Coast in that type of scenario.
Not in that particular scenario exactly, but that is also possible to figure out as well. But there isn't sort of a multi-regional file store offering today, but you can back up to other regions, and you can make a DR solution out of that using those types of tools.
How many file store capability options are there? You mentioned enterprise, you mentioned the smaller one. Are there multiple versions of that, or?
There are three. Filestore Basic, which is, as the name implies, just scale up file store, backup capabilities up to 64 terabytes, moderate workloads. You have a SSD and HDD performance option. Filestore Enterprise is the one that we've just been talking about with critical applications, GKE, and that is complemented by Filestore High Scale, which is the third option for higher performing applications, as the name implies. Filestore High Scale starts at a higher capacity, scales to a larger capacity. Enterprise is kind of the mama bear option, if you will, in terms of availability, features like snapshots, regional availability, things like that. So those are the three file store options.
And then GKE can also use cloud storage as well.
Yep.
You mentioned the continental bucket size bucket thing in the cloud store. How does that play out in the GKE environment then?
Do you want to?
Sure. Basically, so you can choose whatever you create your bucket. You can choose whether you want it to be regional, multi-regional, which is the continental size, or a dual region. And so, so that's generally used for data serving in many cases externally outside of the cloud, right? To provide users providing a high availability and sort of equal time, access time across the continent in terms of getting access to the data.
It's like CDN kind of thing, but not quite.
Yeah, but not quite exactly. But it's for those that really need that higher level of availability and sort of distribution across beyond what is offered just in two different regions.
And you mentioned consistency of the buckets and file systems and stuff like that across multiple nodes, thousands of pods, things of that nature. So I could have any GKE cluster, for instance, update a file and it would appear to all the other clusters that are sharing that file system.
That's right. I mean, so in Filestore, it's just NFS semantics across any of the access points to the individual share. And then on GCS, its metadata is fully consistent.
Yeah.
And then the data, is somewhat eventually consistent.
Yeah. Okay.
So I want to touch briefly on Hyperdisk. And as I mentioned, Ruin is going to dive into this a little bit more, but this is one of the things that is, you can think of this as a next generation persistent disk for our block storage offering. We really wanted to do three things. We wanted to give customers the ability to dynamically provision block storage in a way that we have not done in the past, with basically, you can think of three knobs: IOPS, throughput, and capacity. They can tune for the initial configuration and setup, but then also over time, as that application changes 6 months or a year from now, you can easily dial what that performance is needed for that particular application, or if the capacity changes, you can do that as well. And then Hyperdisk Extreme is, as the name implies, the higher performing option that's going to be available first. It'll be available in preview next quarter in Q4. This is well suited for database workloads, as you can see there. In the middle, we have balanced, which, as the name implies, very broad spectrum of capacity, performance in terms of IOPS and throughputs that you can tune. And then also focusing on applications that need more throughput with Hyperdisk Throughput. Very clever with the namings here, and so that's should be intuitive about what people can look for. The other thing that we're introducing next year is this notion of storage pools. For many of us have come from on-premises world, we love thin provisioning of storage. We are now providing thin provisioning for block storage in the cloud, and that will be available next year. So regardless of which type of Hyperdisk, you can provision more capacity, thinly allocate that across multiple hosts and VMs as needed, and obviously maximize utilization as we have on-premises for years. We'll now have the ability to do that within the cloud.
When you talk about stricter SLOs, would that be where you could say we set a latency target and then it would basically tier you up to the next capability layer because you're blowing your SLO, or would it be a warning? How much is autonomous versus someone gets an alert?
That's a great question for Ruin, and the only reason I'm waiting is because we're almost that time we just need to transition.
Right on.
Moment, but that's a great question for Ruin because he's got all those ideas and talk about that. So I'm going to very briefly just highlight this slide again, just in interest of time. On the left-hand side of this slide is the current provisioning capability and the process for persistent disk. You have an application need. You have to figure out what type of performance you need. In the middle here, you then take into consideration the licensing implications of different vCPU combinations and trade-offs that you want to make in terms of the instance size, the persistent disk option, licensing implications on day one, and if things change over time, or if you don't get it right at the beginning, you rinse and repeat. On the right-hand side with Hyperdisk, it's going to make it much easier to basically decide three things: what that performance capability is, what the instance types that you need are, and then tune those three dials as I described, and you can continually iterate on that over time. If you don't get it right on day one, crystal ball's saying one thing, it's actually something else. You have that ability to remain fluid. The last thing I wanted to share here is actually an architecture slide for SAP. I mentioned Hyperdisk is the first available in preview next quarter, very well suited for SAP HANA and the databases here. This is working in conjunction, again, for those requirements that have multi-zone replication within a given region. Again, you can't see it too well on the projector here, but the kind of the purple are two, and the teal are two zones within one region here, right? On the right-hand side of the slide, that's replicating to another region for a DR capability, right? But within a region, you want to have it highly available. So you use the HRS replication for within SAP, but you have Hyperdisk performance satisfying that high performance need for HANA. But you also have to consider the middle tiers, right? The app, the shared file uses within SAP, and that's where Filestore Enterprise. This is one of the things that we've designed Filestore Enterprise specifically for these types of critical applications that need synchronous replication across multiple zones. In this case, we do it across three. For SAP, it really only matters to do it across two because you're replicating your database across two zones. This is one of the things that SAP actually uses to host their customers within Google Cloud. So underneath the covers, SAP is using Enterprise to deliver their SLAs to their customers of currently 3 nines of availability. And this is what they do with the replication and persistent disk underneath the covers. The last part, and this is one of the things that is also new, is the backup and DR capability for SAP, the application as a whole. And this is what we recently announced. It's almost generally available. Again, in the Cloud Console, you now have a completely integrated Google Cloud backup and DR experience. So on the left-hand side of the console, you can choose your backup for GCE, GCVE, and you can actually pick and choose your policy, apply it to different applications and even other databases as well. And so we're not going to do a deep dive or a demo into this area today, just in the interest of time, but I did want to highlight it because it's one of the capabilities that is now afforded customers across, you think about GKE, GCE, GCVE, and other database workloads. you can see where we're going overall as a strategy for not only
You
providing
mentioned
storage
Filestore Enterprise has synchronous recovery across regions and across.
across zones.
Zones,
There was a
multiple
third-
zones
There
within
was
a
a
region.
third zone in a different region on that slide. Is it not? It's not doing synchronous recovery.
So this slide, I just showed 2 zones in one region. This bar region here is for DR capabilities, but there would be a third zone within this first region that
Potentially
Filestore
could be
Enterprise.
synchronously. Yeah.
It is because it's not a configurable option. They just choose capacity and go in the region, and then we underneath the covers synchronously replicate it to 3 zones. So there's no administrative overhead to do that.
But there's no synchronous replication for persistent disk, or is that another option here?
In this slide, it's done at the SAP application layer, at the database layer. SAP HRS is doing the database.
I understand it from a software perspective, but as from persistent disk
Oh.
perspective,
it does,
Yeah,
yeah. They
yeah.
have regional persistent disks
Okay.
that you can get as well.
I thought you were asking about the SAP app, but yes, or regional PD.